Dear children, I am clapping my hands. I am knocking at the door. Then I will speak on the mic. Hello. When we use musical instruments, then I will drop down the. At that time, there are some vibrations and there is sound that is produced at all times. See, when I try to whistle on this, there is production of sound. If I drop down this into the water, at that time what will happen? There will be the vibrations, production of vibrations, and due to these rhythmic vibrations there is production of sound. This is we are going to study in chapter 18 and the name of the chapter is sound. See, some sound vibrations they can be felt whereas some vibrations cannot be felt, and that's why sound is generated due to rhythmic vibration of an object. There are no doubt vibrations, but some vibrations they can be felt by us and some vibrations they are very low and that's why we cannot feel them. Sound is generated due to rhythmic vibration of an object that we have just studied. The pitch of sound depends upon its frequency, and in the Indian musical instruments, what happens? If there is tanpura, if there is guitar, sitar or any drum, tabla, at that time, what we do? We try to set it so that the required pitch can be obtained. While playing tabla or drum, the diaphragm it is adjusted so that there will be the required pitch of the sound. When we play guitar or tanpura, at that time the strings they are set so that the pitch will be there. In this way, for every instrument, there in Indian music the musical notes are there, and in general, if you play on harmonium, there are some musical notes sa, re, ga, ma, pa, dha, ni, and these are increasingly in higher pitch. Then this frequency it is a measure of pitch. Now we are going to study oscillatory motion. See, I had taken this thread and I had tied a stone to it so that it has become like a pendulum. Now, this is the central position here, and if I want to move it, what will happen? It will move like this. From central position A to B, A to B. Like that, there is one oscillation completed when it comes back to its original position. And there is back and forth movement. See, back and forth movement of oscillator on either side of a central position is called oscillatory motion. This is an oscillator. Now, a swing. In swing, you see when the swing is in stationary position, at that time that swing it is not having movement. But when we sit on that swing and when we try to move it, at that time we go backward then forward, backward then forward, and this happens. It is also seen in sitar strings, then bird's wings, this pendulum. All these are the examples of this oscillatory motion. Now, we are going to study some terms those are related to oscillation. For example, amplitude of oscillation. For studying amplitude of oscillation, on page number 122, the activities are given. For example, if this is a pendulum, you have to increase the length of this thread and you have to note down the time period, and after noting the 4 to 5 readings, you have to make conclusion about it, and that activity you have to do. It is very easy. Amplitude of oscillation, what is it? Maximum distance between original and extreme position is called amplitude of oscillation. See, the maximum distance between original to extreme position is called amplitude. Then, time period of oscillation. Time required by an oscillator to complete one oscillation. See, time required by an oscillator to complete one oscillation is called time period of oscillation. Then frequency of oscillation. Number of oscillations completed by an oscillator in 1 second. See, here is also a pendulum, and this pendulum is moving back and forth, having oscillatory motion, and in this also we can describe it amplitude, then the time period and frequency. Number of oscillations completed by an oscillator in 1 second is called the frequency of oscillation. What is the formula for frequency of oscillation? Frequency is equal to 1 upon time period of oscillation. N is equal to 1 upon T, and this frequency is denoted by unit hertz, and hertz is written in short Hz like this. Now, elasticity. What is elasticity? A stretched rubber string. See, rubber, it can be stretched like this, and when it is released, it comes back to its original position. When this stretched rubber, when it is released, it comes back to its original position, and it is called elasticity. The rubber band, then elastic, these are having elasticity, and this property is useful in this rubber. In this way, sound, it is generated due to the vibrations that we have to understand. Without vibrations, there will be no production of sound, and we have to do some small activities. Those are related to sound, and those are given in our textbook. Thank you.